All right. So let's see if I can find. Simon, I need something a little more specific than that because sometimes we can factor and sometimes we can't. So do you want to see a version where we can factor straight off the bat, or one where we have to guess and check with random numbers? I am going to go ahead and start with that very first question, though, about how to do long division. So I'm just taking the one from the quiz. This is quiz question number 5. That is a very large font. Let's see if we can make that a little smaller. Okay. We can do both. And so on the quiz, it had this problem, and I'm going to go ahead and just set it up right now. And so the thing that's being divided goes on the outside, so it was x minus 4 was after the division sign, and then we were dividing 2x to the third minus 3x squared minus 18x, and then minus 11. And one of the things that I like to do on these problems, because I think the most difficult part of this problem is the fact that you have to do subtraction. And so I like to kind of focus on my signs a little bit right now. And so my original signs right now for the thing I'm dividing by, the x minus 4, the x is positive and the 4 is negative. And so when I change this to a subtraction problem instead, then the x would become a negative and the 4 would become a positive. And so I'm just going to kind of keep those symbols in mind when I'm doing the underneath part of the division problem. Jim, are you asking me to help you with that, or are you asking if it's going to be on the test? And the answer is yes, it will be on the test, and we can definitely review that if you need us to. All right, so starting this long division problem, your first goal is you're going to look at the very first term, which is x, and you're going to look at the first term underneath the square root, or not the square root, the division symbol, which is 2x to the third. And you need to think of, what should I multiply this outside x by so that it will be matching with this 2x to the third on the inside. And so x times 2x squared would become 2x to the third. And so then I'm gonna do that. I'm gonna do 2x squared. I'm gonna multiply it by the x, and that is 2x to the third. And then the trick is you have to do distributing. So you are going to do the 2x squared also times the 4, and that becomes an 8x squared. And then we said that long division is a subtraction problem, and so this x was originally a positive, but it's subtracting, so I'm going to make it a negative. And the 4 was originally a subtraction, but when you subtract a problem that's already subtraction, it gets this like double negative thing, and it becomes a positive. And so I'm using these symbols right here, the negative and the positive. And the goal is that, the first one's going to cancel out. And that should always happen. And the second one's not going to cancel out. The second one you're going to add together. So negative 3 plus 8 is 5x squared. We're going to bring down the next term, minus 18x. And we're going to do it again. So now I want the x to match with the 5x squared. And so I need to multiply by a positive 5x. And we're going to distribute that again to the outside. So 5x times x is 5x squared, but I'm subtracting it. And then 5x times the negative 4 is negative 20x, but I am subtracting that, and so it'll change into a positive 20. And so again, the signs on the red writing, they need to be the opposite of whatever signs were in the original problem. And so again, I'm using this minus and this plus down here. The first ones cancel. Negative 18 plus 20 is 2x. I'm going to carry down my very last term, which is negative 11. And we're going to go for it one more time, and this will be the last step of the long division problem. So this time I'm matching the x with this 2x right here. So I've already got the x going for me. All I need is the 2. So I'm going to multiply by a positive 2. Notice on top that your variables have descending exponents. It goes x squared x, and then the last one doesn't even have an x. That's when you kind of know that you're going to be done. All right, so now I'm going to do 2 times x, which is 2x, but I'm subtracting it. And then we do 2 times negative 4, which is negative 8, but I'm subtracting that, and it becomes a positive 8. The first ones cancel. Negative 11 plus 8 is negative 3. This is your remainder. For a final answer, you want all those numbers and letters I was writing in blue at the top. So 2x squared plus 5x plus 2. And then if there's a remainder, you kind of tack it on at the end. You add it as a fraction. It's really important that you have some sort of symbol between the constant and the fraction. So I put a plus sign. Since your remainder was negative, you also could have subtracted a 3 on top of the fraction. And then underneath the fraction, you put the x minus 4 that you were dividing by. And this ginormous thing would be our final answer. So that was long division. Sorry, grabbing a really quick drink there. Okay, long division. Okay, so Gavin and Simon, you kind of had the same question a little bit. 12 and 13 are finding x-intercepts from an unfactored form, but 12 and 13 both can't be factored straight away. And so we'll practice that first, and then maybe we'll go back to the front of the quiz, or if somebody has a different type of problem, and we can practice what to do if the problem can be factored from the original format. But for right now, let's take a look at number 12. So this was, and you don't, it doesn't really matter about like the f of x or the y, or like, we're just going to focus on the other side of the equal sign. So we have 3x to the third minus 4x squared minus x plus 2. And the very first thing they want us to do is find out how many, it says use Descartes' rule of signs to find the number of positive real roots, negative real roots, and imaginary roots that this problem has. And so this is the one where you are counting the amount of sign changes that are happening in the problem, as you want to point out that this first number 3 is a positive number 3. Okay, so the first term is positive, the second term is negative. That is a sign change. I'm going to put a y for yes. Now we have a negative, and this one is also negative, so that's a nope, because those are both negative. And then we have a negative followed by a positive, and so that's a yes. And so, yeah, we totally can do that a little bit later. And so from the original problem, I'm counting 1, 2 yeses. Now when you're doing the yeses from the original problem, you're counting how many positive answers there are. And normally we make like a table. Positive, negative, imaginary, and I like to add an extra column. That's the total. Now the total column is how many total answers this problem has, which is based on its largest exponent, which is 3. And so at this point in time, counting 2 yeses, I can say that there can be 2 positives. And whenever we have an even number, we want to count down by even numbers until we get to the number 0. So I'm also going to say that there can be 0 positives. Next, we take the original problem and we change all of the signs of anything that it has an odd exponent. For instance, x to the third, I'm going to change that to a negative 3x to the third because that exponent 3 was odd. My next one is an x squared. I'm not going to change that sign. It was minus 4x squared. I'm going to keep it a minus 4x squared. The next one, x, that's technically an x to the first, which is an odd number, and so I'm going to change that to a plus x instead. And then 2 does not even have a variable, so I'm going to leave it a +2. And we're going to do the same thing where we count the sign changes. So I have a negative followed immediately by another negative. That's a nope. I have a negative followed by a positive. That's a yes. And I have a positive followed also by a positive. That's another no. And so I'm counting only one yes here. Yes, it stays the sign stays the same as the original problem if it has an even exponent, or like the last number 2 was a constant, that would also keep its original sign. All right, so I counted one yes, and when you have an odd amount of yeses, you count down by odd numbers to the number 1, but the 1 is already the number 1, so that's it. For negative answers, there's definitely one negative answer. Next, what I need to do, I'm going to look for my imaginary answers, and the amount of positive answers plus the amount of negative answers plus the amount of imaginary answers should equal the total answers that I have for this problem. Okay, so on our first line of the column, I have 2 positives plus 1 negative plus some unknown amount, and I want that to equal 3. Well, 2 plus 1 is already 3, and so I really don't need any imaginary, so I'm going to put a 0 there. For my second row of my chart, I have 0 positives and 1 negative, and I want that to equal 3. Well, right now I'm only at 1, and so if I want it to equal 3, I would need 2 more. And so for imaginary options, there are either no imaginary answers or there are 2 imaginary answers. So this is the first part of problem 12. This again is called Descartes' rule of signs. For the second part of problem 12, we need to list all possible rational roots. So this is when you list out every possible answer that there is. They're not all going to be answers, but it's the things that, like, then we're going to do this guess and check thing where we try and see which one works. When you're listing all possible answers, you're going to focus on the last number of the problem, and you're going to list all of the numbers that can multiply together to make the number 2. And that's pretty simple. It's just 1 and 2. Now you also have to check and see if there's a leading coefficient, if there's a number in the very front of the problem. And in this problem there's a 3 up here. When there's a number in the very front of the problem, that means you also have fractional options. So what you're going to do is you're going to take the very front number, the first number, and you're also going to list out all of the numbers that multiply to that. And so the numbers that multiply to make 3 are 1 and 3. Finally, you're going to list every option of how you can make a fraction out of the factors of 2 and the factors of 3. The factors of 2 must be on top and the factors of 3 must be on the bottom. So I'm going to start with the very first thing that I see, which is 1 over 1, and that's just number 1. Then I can try 2 over 1. 2 over 1 is just the number 2. Next, I can try 1 over 3. And finally, I can try 2 over 3. And so these are all the different scenarios that can happen based on those 4 numbers. And then we need to put plus or minus signs in front of all of them. And this would be the answer to part B from the quiz that said list all possible rational roots. So these are the possible numbers that might be answers to this problem. PQ is right. I think it's, I don't remember if it's P on top or Q on bottom. I just remember the last one goes on top and the first one goes on the bottom. All right, we're ready for part C. Part C is where you break out your handy dandy calculator and you start typing these numbers that we just wrote in this list into the original problem until one of them spits out an answer of 0. I always like to start with the number 1, and I like to check my whole numbers first, and I kind of cross my fingers and hope it's not the fraction number. I'd also like to point out that we've decided that this problem can have 2 positive answers, so it's a good idea to check the positive numbers. And actually, the very first positive number we check, it's going to work. So if you type into your calculator 3 times 1 to the third minus 4 times 1 squared minus 1 plus 2, the calculator will tell you that the answer is 0, and that's what we're looking for. No, we're going to have one more. It's about 2 weeks long, one more unit after Thanksgiving break. It's kind of like the parabola unit, but a little bit less calculating math. It's very heavy on graphs. And so there will be one more test. So we come back for a week, and then that following week on Friday, there will be a test. And then the week after that is finals. All right, so you plug in the number 1, it gives you an answer of 0. We say, yay, that worked. And then you go over to your answer line, and as soon as you find a number that when you plug it in gives you a 0 and that number works, you write that number on the answer line. So I'm going to write the number 1 on the answer line. And then you take that number, the number that when you plugged it in worked, and you do synthetic division with it. So I'm going to put the 1 in the little box for synthetic division, and then we have 3, -4, -1, and 2. And I have chosen this number 1 because I'm pretty sure it's going to give me no remainder. And that's exactly what happened, no remainder on that. So now I've done synthetic division. I have 3x squared minus x minus 2. And so now I need to keep working. And at this point in time, with something this small, it's a trinomial with an x squared, you can try factoring. And this is factorable. It does work. If you're familiar with Xbox, we multiply the 3 times the -2, which is -6. And we take the middle number, which is -1, and that would be -3 and 2. Now, because of this 3 in front of the x squared, we are going to need to do a little bit more work. You can do the box, or you can do factoring by grouping if you prefer. If you've watched any of my other videos, you know that I love the box method. It's my favorite. And so I'm going to fill in my box. Factoring is all from chapter 4, so if you need to go back and review your factoring, you can go back and look at some chapter 4 notes. When I'm done factoring this, I get these 2 parentheses, 3x plus 2 and x minus 1. And so I can set those each equal to 0. And then I will get my other answers. Remember that we said that this problem should have 3 answers total. Okay, so I've got 1 so far, it's the number 1, and then here's a second answer, which is -2/3. Now for my third answer, I'm getting the number +1 again, and I've already gotten the number +1. So what I'm going to do is I'm going to say that the number 1 has a multiplicity of 2, or whatever your teacher told you to write. So I know in previous chapters we called it a double root. I don't know if your teacher told you to write the number 1 twice. I've been really emphasizing with my students that if it happens more than once, it's called a multiplicity. And so we write M2 after it or under it to tell us that it counts as 2 answers. And that is the end of number 12 from the quiz. All right, let's dive into number 13. Number 13 is going to be a little more extensive than number 12. There it is. Okay. So this is quiz 13. X to the 4th, 3x to the 3rd, 3x squared, 11x, and 6. All right, let's start with Descartes' rule of signs. So I am counting, this is technically positive, so positive to a negative is a yes, negative to another negative is a no, negative to a positive is a yes, and positive to a negative is also a yes. So I am counting 1, 2, 3 letter yeses. And then we said earlier, if you have an odd amount, you're going to count down by odd numbers to 1. So 3 and 1. And this first counting of yeses, and we don't do anything with the no's, we're just looking at the yeses, that tells me how many positive answers I can possibly have. And so right now I have an option of 3 positive answers or maybe only 1 positive answer. Just a little side note, while we're here, the total amount of answers this problem has is 4. So I'm going to go ahead and fill in my total column with that number 4. Okay, now I'm going to change the signs of only the odd exponents. So x to the 4th, which is even, will not change. That is supposed to be a 4. X to the 3rd is an odd, so I'm going to change that to a plus 3x to the 3rd. X squared is even. I'm going to keep it minus 3x squared. And then 11x to the 1st is odd. I'm going to make that minus 11x. And then 6 is not even a variable, so I'm going to keep it a minus 6. A positive to a positive is a nope. Positive to negative is a yep. A negative and another negative is a no, and a negative and another negative is also a no. And so here I'm only counting 1. And we're supposed to stop counting when we get to the number 1, and we are already there. This was counting, again, the amount of negative answers. This one was counting positives. So I have the option of 1 negative answer. And so the last thing I need to do, I need to add these numbers together and figure out what's missing to equal 4. And so 3 plus 1 is already the number 4. And so I'm going to fill in the imaginary with 0. 1 plus 1 is 2, but I want it to equal 4, so I have 2 missing. And so my imaginary options, again, are 2 or 0. I'd also like to point out that your imaginary options, they always have to come as a pair of numbers. There should be 2 of them, or 4 of them, or 0 of them. And so it's really important in the imaginary column that you are always getting an even amount of numbers. If you ever get an odd amount of number, if you ever put like the number 1 in the imaginary column, you made a mistake. You can't have an odd amount of imaginary answers. Okay, let's do part B, which is list all the possible rational roots. Lucky for us, this problem has a constant and it has no leading coefficient. So all I have to do is figure out all of the numbers that multiply to make 6. And that's them. And so that would be the answer to part B. Now it comes the very long part of the problem. And so this is the part where you take your optional answers and you plug them into the original question until the calculator gives you an answer of 0. I, again, always like to start with 1. I hope it's a small number. I hope it's a positive number. It just makes my life a little easier. And just like on the last problem, 1 will work. If you plug in 1 to the 4th minus 3 times 1 squared, to the 3rd, sorry, minus 3 times 1, now it's squared, plus 11 times 1 minus 6, the calculator will give you an answer of 0. So over here, we'll write out our answers, and that we've just discovered that one of the answers is 1. And then we do our synthetic division. We use the number that we plugged in exactly how it was. So if you plugged in a 1, you're also going to put a 1 on your answer line and in the box for synthetic division. And then we use our coefficients. And if I did this right, it should give me a 0. And there it is. And so I've created a smaller problem. My original problem had an x to the 4th. My new problem has an x to the 3rd. That's fantastic. We're moving in the right direction. Now here, I normally ask myself, can I factor this? And since this has 4 terms, my first instinct is, oh, I should put it in a box and see if I can factor. So this would be an x squared, x, -2. Now on this column, we're going to run into some issues. To make this box work, this would need to be a -5. However, -5 times -2 does not make 6, it makes 10. And so because when I try to factor, it does not work, this is not factorable yet. And so what I'm going to have to do instead, I'm going to have to plug numbers in and hope for an answer of 0 again, just like we did at the beginning. And so you can plug in the same numbers that you used earlier. You can even plug in the same number you already used. You can try 1 again. Maybe 1 is a multiple root. And actually it is. When you plug in the number 1, 1 to the 3rd minus 2 times 1 squared, and we're plugging it into this new one, not the original. We already know it works in the original. Minus 5 times 1 plus 6. You type that into your calculator and you will get an answer of 0, which means that this answer of positive 1 has a multiplicity of 2. It counts as 2 separate answers. And so I can do synthetic division again. I'm going to put that 1 back in the box. I'm going to use my new coefficients from this problem right down here. So 1, -2, -5, and 6. And we're doing synthetic division until we get the problem to be small enough that we can either factor, or if we can't factor, we can do quadratic formula. Now you can't do quadratic formula until your biggest exponent is an x squared. And so actually right now, and maybe we'll section this off a little bit because this is starting to become a lot of writing right now. So I'm right here. I have an x squared. So I have x squared minus x minus 6. So this, at this point in time, if I cannot factor that, I could do quadratic formula, and I wouldn't need to do the guess and check synthetic division anymore. Well, lucky for us, this is factorable. 2 numbers that multiply to -6 and add to -1 are -3 and 2. Since there is no leading coefficient, I can go straight to my parentheses. And then this one will give me an answer of 3. And this one will give me an answer of -2. Now remember, we're supposed to have 4 answers, but I only wrote down 3 numbers. And again, I only wrote down 3 numbers because technically my first number counts as 2 answers. So even though there's 4 answers, there's only 3 on the answer line because the first one counts twice. Oh no, there went my coaster. Okay, that was number 13. 5 on the review sheet. All right, number 5 on the review sheet is a problem where you start off straight away by factoring. And so you don't have to do this whole list out all the possible numbers and guess and check and all this stuff. You just go straight to factoring. Oh, because we did it with synthetic division twice. So the first time that we divided by the 1 right here, that counts as 1 answer. And then when we decided that we could do it a second time, that's when we said, okay, that counts as 2 answers. So the fact that we could divide by the 1 twice, 2 separate times, that's why it has a multiplicity of 2. Whenever you do something whenever you decide to do synthetic division with a number, you're saying that number is an answer. Okay, so I'm looking at, this is the review I gave my students. I'm not sure if all teachers gave the same review. This is our review from last year. Oh, so maybe I should make sure. Oh no, you're my student. I'm pretty sure you're my student. So not all the teachers might have given this one. I'm not 100% sure. This was the review that we gave last year, and I liked this review because it went over a lot of stuff. So it said 9x to the fourth minus 48x squared plus 64 equals 0. And then this is a trinomial, and so you can try Xbox with it. Oh, I need a calculator. 9 times 64, 576. Okay, 576 and then negative 48. Now, that is an insanely ginormous number. When you get a really, really big number like that on Xbox, it's probably a perfect square trinomial, which means that the sides of the x's should be the same number. Now, you can either find that number by taking the square root of 576, or you can take the 48 and divide it in half. And so negative 24 should be the sides of the x. And you can double check that and make sure 24 plus 24 is 48. 24 times 24 is 576. From here, again, because of this 9 out front, you can either do the box or you can do factoring by grouping. I will do both because somebody asked about factoring by grouping earlier. So here's the box, my best friend. The box, that's a 2, not a 1. And so we have 3x squared. Notice that we're putting x squares and not x's. Okay, and so I get 3x squared minus 8 and 3x squared minus 8 again. If you want to do factoring by grouping, what you would do, instead of going to the box, you would take these two negative 24s and you would take this negative 48x squared and you would split it into a negative 24x squared and a negative 24x squared. So you take the sides of the x and you use that to split up your middle term. And then you would group together the first two and the last two. You would factor out what they have in common. So the first two have in common a 3x squared. And the last two have in common a negative 8. And then your goal is that these two parentheses should be the same parentheses. And when you get them to both be the same parentheses, then that's what goes up front here. You'll see, right, we have this 3x squared minus 8. And then whatever you factored out, it goes in its own parentheses right here. And so in this problem, it happened to both be 3x squared minus 8. Yeah. Just on the off chance we don't get to number 13 on the review, I will tell you that negative 1 works as an answer. It has a multiplicity of 2. You should do synthetic division with negative 1 twice for number 13. If we have time, I will definitely do that problem, but just if you need something to help you get started, you can start with that. All right, now these are the same parentheses. That means that whatever answer I get, it will have a multiplicity of 2, because I'm going to get it for this parentheses, and I'm also going to get it for that parentheses. And then I really only have to solve one of them. When you get to this point in time with the x squares, your next step is going to be to square root both sides. And then we just have to remember that anytime that we choose to write a square root symbol into a problem, we have to put a plus or minus sign in front of it. And so the answers, plural, to one of these parentheses is a positive version of the square root of 8 over 3 and a negative version of the square root of 8 over 3. And so, right, so this one parentheses, it gave me 2 answers. And then since I had that same parentheses again, we would say that this one has a multiplicity of 2, and this one also has a multiplicity of 2. So that got a little fancy. Question 6. There can be. Question 6 is actually not a difficult math problem. It just looks really difficult because of how it's worded. It's a lot of words to read. On question 6, all that you should have done is you should have taken the x minus 2. You should have changed the sign, so you should use a positive 2. And then you're going to plug in a positive 2 to all of the options. And 3 of them will give you an answer of positive 3, and the third one will give you an answer that's not positive 3, and that's the one you want to choose. Yeah, 14 is the pyramid, and you need to be able to recreate the pyramid on your test tomorrow, because we're not going to give the pyramid to you. So you're going to have to be able to create it down to whatever row you happen to need. Is Simon still? Simon, are we good now on solving by factoring? Do you need to see a factoring by grouping one still? Because I have one more example of a factoring by grouping that we can do. Okay, so I'm going to do from my review worksheet, I'm going to do question number 6, which is 3. I'm going to change it to x's instead of t's because t's are hard to write. So 3x to the third minus 2x squared minus 12x plus 8. And so this one is in a section that specifically says factor. And so if the directions say factor, like that means this thing is factorable and you should try to factor it. And this thing has 4 terms in it already, so I'm just going to jump straight into grouping them together. Notice that I kept the negative symbol with the 12. And what you do is you look in each individual parentheses for what they have in common. So in my first parentheses right here, 3 and 2 don't have any numbers in common, but they do have an x squared in common, so I'm going to factor out an x squared. You can do synthetic division for number 6, but oh my gosh, that is so much more work than you have to do. I'm telling you, just type in a 2 where anywhere there's an x. So for like letter A, you can do 4 times 2 minus 5, and it's 3. And you say, okay, that's great. It said it was going to be 3. And then on the one right underneath it, you do 2 to the third minus 2 squared minus 5 times 2 plus 9. And your calculator will tell you 3, and you're like, okay, great, that's what I'm looking for. And then when you type in the second letter B, the one that's on the top row, 2 times 2 squared plus 2 minus 13, that actually gives you a negative 3. And that's the one that you should have circled because it was not a positive 3. And that just goes so much faster. But you absolutely can do synthetic. You could also do long division if you really, really wanted to. If you liked long division, you could have done that instead. Then we look at this one and we factor out what they have in common. Now, we're hoping that this parentheses turns into the same thing as this one. So 12 and 8 are definitely divisible by 4. And then my first parentheses has a positive 3x and a negative 2. This one right now has a negative and a positive. And so to change those signs, I'm going to factor out a negative 4. And so 12 divided by negative 4 is positive 3. And then 8 divided by negative 4 is negative 2. And so it's really important that these two parentheses are the same. And once we get them the same, we're going to put them up front. It's kind of like factoring out a GCF. It's something that they have in common. And then these things that we factored, those go in their own parentheses, like so. And in this particular problem, this can be factored more. This is called a difference of squares. So we can square root both numbers and do one with a plus sign and one with a minus sign. This is just still kind of part of the problem. And so this is factored. And then if I wanted my answers, I get 2/3, negative 2, and positive 2. All right, we did 12 and we did long division. We did 12 and 13. We did factored and unfactored. Jim, did you still need help with 1 and 2 from the quiz, or we just, it's definitely going to be on the test. You need to know the vocabulary words. I can run through them really quick if you need to. We did factor by grouping. We did 5. Okay. So there's two different lists of vocabulary words. One is degree, and that's based on the exponent. And then the other one is based on how many terms there are. One term is called a monomial. Two terms is called a binomial. Three terms is called a trinomial. And anything bigger than a trinomial is called a polynomial. And this is usually the second word that you write. So monomial is one thing, binomial is two things, trinomial is three things, and anything bigger than three is called a polynomial. Now degree is based on the biggest, I should write, the biggest exponent in the problem. And so if a problem doesn't even have a variable in it, if it's just a number and there's no letters at all, that's called a constant. Yeah, I think somebody else requested those. That might be next on my list. If the biggest exponent is x to the first, or just the letter x, that's called linear. X squared is called quadratic, like the quadratic formula, right? Because quadratic formula can solve x squared. X to the third is called cubic. X to the fourth is called quartic, like quarters. X to the fifth is called quintic. And then anything bigger than that, you're just like 6th degree, 7th degree, 8th degree, and so on. And so those are the vocabulary words. We usually write the degree word first and the term word second. You want to pick one from each list. So you had a lot of people who tried to tell me it was like a binomial trinomial or a cubic constant or something like that. So just make sure you're only using one from each list. All right, so now we are up to 10 and 11 from the quiz, and we can also talk about number 9 since you also wanted to know about number 9. Let's start with number 9 because that one's kind of easy compared to the other ones. Not necessarily easy, but comparatively speaking. So on number 9, they told you the answers. Somebody solved a math problem, and when they solved that math problem, they got the answers -5 and 3 and 0, and they want to know what was the original math problem. And so what you have to do is you have to think about, like, how would I get an answer of -5? Like, what would have given me that? Yeah, I'll probably be there a little bit after 7, probably like 7:10. Okay, so to get an answer of -5, I would need to have something that was like x plus 5, because then I would like set that equal to 0, and I would subtract the 5 to the other side, and it would turn negative. And to get an answer of a +3, I would have needed a parentheses that was x minus 3. And so basically you're just taking the numbers, you're putting them in a parentheses with an x, and you're changing the sign. So if it was negative, make it adding, and if it was positive, make it subtracting. And then anytime you have an answer of 0, that means that you had a GCF of the letter x. So I'm going to put an x out here. Now they want the final answer in standard form, so we are going to have to multiply these things together. I would highly suggest that you start by multiplying the two binomials together. And then as if like the last thing that you should do is the distributing. Okay, so if you understand, I'm going to breeze through a little bit of it. So when I multiply these two together, we get x squared plus 2x minus 15. But there's still this x on the outside, and then we would distribute that, and we get x to the third plus 2x squared minus 15x. And then that would be the final answer. So that was question 9. And then question 10 is a little bit trickier. And this actually will go into, somebody asked about 7 and, oh, I don't know if that was 7 and 8 on the quiz or the review. Well, this is 7 and 8 on the, where's 7 and 8 on here? No, it's probably from the quiz. 7 and 8 from the quiz actually have a little bit to do with numbers 10 and 11 on the quiz. And so number 10 says somebody solved a math problem and they got answers -3 and 2i. Now, they did not get only those two answers. There is no way that those are the only two answers that they got, because imaginary answers have to come in a pair. Imaginary answers always come with a plus or minus sign in front of it. And so if they're telling me that they got an answer of +2i, I know they also got an answer of -2i. And so I'm going to write it in. Even though they didn't tell me, I know it's there. And so I write that one in. Now that's kind of what they wanted you to do on numbers 7 and 8 from the quiz. They wanted you to write in the missing ones. So like on number 7, they told us square root of 5 and -2 plus 4i. But I know that the square root of 5 had a plus or minus symbol in front of it, and I know that the 4i had a plus or minus symbol in front of it. And so they want the ones that were not written down. And so the test gave me, or the quiz I should say, because this is the quiz, gave me the positive version of rad 5, and so I write down the negative version of rad 5. And the test gave, or the quiz, I keep saying test, the test is tomorrow, this is not the test. The quiz gave me the version where the 4i had the plus sign in front of it, and so it wants me to say the version where the 4i had a minus sign in front of it. Now notice that I didn't take the -3 and also write a +3. You only have to do this with i's and rads. So on number 8 had a little trick to it. It was a 3/2 and it was a 1 minus 8i. They wanted you to only write the partner for the 1 minus 8i. The 3/2 does not have to have a partner, just like this -3 does not have to have a partner. All right, and then we write out some parentheses and we do a little multiplying. So my -3 turns into an x plus 3. My 2i turns into an x minus 2i. And then the -2i that I wrote down, because I knew it was there, turns into an x plus 2i. And then in a desperate plea for you to keep your sanity, you're going to multiply the I parentheses together first. You should never, you can. I wouldn't ever multiply an I parentheses with a parentheses that doesn't have an I. You're just going to create so much extra confusion and work. So make sure you're always multiplying your I parentheses together. This is going to turn into x squared plus 2ix minus 2ix minus 4i squared. What ends up happening is these will cancel. And then we learned, in a couple chapters ago, we learned that I squared is the equivalent of -1. And so that means that this part right here, it's actually saying -4 times -1. And -4 times -1 is +4. And so this crazy thing with my letter i's turns into x squared plus 4. Now we haven't dealt with the x plus 3 yet, so we will need to multiply by that. And then you do want your final answer to be in standard form, so it needs to be in descending order. So the final answer for number 10 would be x to the third plus 3x squared plus 4x plus 12. Number 11 is very similar, except for instead of having an I answer, it has a rad answer. So this is quiz number 11. They gave us -2 and the square root of 5. And so we know that if there's a positive square root of 5, there also had to have been a negative square root of 5, so we're just going to fill that in. Again, we don't fill in a +2 because there was a -2. This is only for rads and i's. I get x plus 2, x minus rad 5, and x plus rad 5. And just like on the I problems, you definitely want to start this problem by multiplying together your radical parentheses. So you definitely don't have to multiply the first and second one together. You can pick whichever ones you want. And I want to multiply my rads. I want to multiply my rads because they are very conveniently going to make all the radicals disappear. One of the first things that disappears, these middle terms cancel out. And then this last one, I know what the square root of 25 is. It is 5. And so I can change that to just x squared minus 5. I did, hun, yeah, probably around the middle, like 8:20, 8:30, I think. So when we finish up and the recording gets posted, if you just scroll to around the middle of the recording, you can see numbers 12 and 13 done. I would check about 10 minutes after we're done. After the session is over, the recording should be posted. All right, so again, if you multiply the radical parentheses together first, all the rads will disappear. They'll turn into nice, pretty numbers. I will say that these problems will never have a radical or an I in the final answer. And so if you are ever getting a radical in it or an I in this part, you made a mistake. You did something wrong. This part should look normal. It should look very similar to how like 12 and 13 look from the beginning. So just make sure that there are no more rads or I's when you're done with this type of problem. 10 and 11 from the quiz. 7 and 8. We talked about 6. Okay, I think the last, and we've only got 5 minutes, so I don't even know if I can finish this in 5 minutes, but and David is still logged on. Fantastic. Is number 13 from the review. So this is, again, the review that I gave my students. And so if you're not my student, I don't know that you have this worksheet, but they're good problems for us to practice. So this is from my review, number 13. Cassie, this is also going to be very similar to numbers 12 and 13 on the quiz. So another good review of that type of problem. Okay, so the first thing, and actually this review sheet had like one extra little answer line thing. The first answer that it wanted was how many answers does this problem have? That was question A. And so this problem has 4 answers. Okay. The next thing that the problem wanted you to do was Descartes' rule of signs. So let's practice that one more time. And so I'm just going to count the sign changes. Now, I mean, just staring at this, they're all positives. There's not going to be any sign changes. This is a no, 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 and no. And so if I go over to my lovely chart, there are no positives. There's no sign changes in the original problem. This question's not going to have any positive answers. Then I go through and I change all the signs of anything with an odd exponent. So I'm going to keep my 3x to the 4th, but I'm going to change it to a negative 11x to the 3rd. I'm going to keep my positive 14x squared, but I'm going to change it to a negative 7x, and I'm going to keep my plus 1. Now here I've got some negatives, so I should definitely get some yeses. So positive to a negative is a yes. Negative to a positive is a yes. Positive to a negative is a yes. And negative to a positive is another yes. And so I actually end up with 4 yeses. And this was after I changed my symbols. And so this is counting my negatives. Now, when you count an even amount of yeses, you need to then count down by even numbers until you get to 0. So that would be 4, 2, and 0. And so that is the amount of negative answers I can get. I can either have 4 negative, all 4 answers are negative, 2 of them are negative, or none of them are negative. Now I still only have the option of 0 for my positives, so I'm just going to line that up so that I have something to go with. And then in my total column, we decided from part A that I should have 4 total. So I can go ahead and fill that in as well. Remember that these three numbers should add up to 4. 0 plus 4 is already 4, and so I don't need any imaginary. 0 plus 2 is only 2, and I will need 2 more to get to 4. And 0 plus 0 is 0, and so then maybe all 4 of my answers are imaginary. And so here you can find the answer to part B, which is how many positive, negative, and imaginary answers can this problem possibly have? Next, for part C, we are going to list out the possible answers that this problem can have. This problem is very limited. Our constant is the number 1, and the only number that multiplies to 1 is 1. But we do have that option of a fraction, because we do have a leading coefficient of 3. And so the numbers that multiply to make 3 are 1 and 3. And so my options for possible answers, 1 over 1, which is just 1, or 1 over 3. And so these are my possible answers that might work for this problem. Okay, now I'm supposed to start plugging in my options, my positive 1, my negative 1, my positive 1/3, my negative 1/3. I'm supposed to plug those into the original problem. And this is where it's really important that we go back and we look at Descartes' rule of signs. And we look specifically at the positives. I have decided that this problem definitely does not have any positive answers. And so when I'm doing my guess and check, my plugging in, I'm not going to plug in positive numbers. I can't get a positive answer. That would be a waste of time. And so normally I would say, okay, start by plugging in positive 1. But since I'm sure that the positive will not work, I'm going to say let's start by plugging in. Let's plug in negative 1 instead. So 3 times negative 1 to the 4th, plus 11 times negative 1 to the 3rd, plus 14 times negative 1 squared. And I'm typing this all in my calculator, right? I'm letting my calculator do the work for me. And very, very nicely, very conveniently for us, that does equal 0. And so we say, yay, and we have found our first actual answer, which is what answer line D wants. It wants actual answers. And so I'm going to write negative 1 there. Now, since negative 1 works, I'm going to use it to do some synthetic division. And there's that 0 remainder, just like I was expecting. And so now I've taken a problem that was an x to the 4th, and I've kind of knocked it down a notch. I now have an x to the 3rd. Now, normally I would say, hey, try to factor this. I'm going to tell you right now, this is not factorable. Mostly I'm looking at the 8 and I'm looking at the 1. The 3 and the 6 are fantastic. 3 and 6, those go into each other. But 8 and 1, that's going to screw me up. So I'm going to go ahead and say this is not factorable, and I should restart my guess and check process. Now, you are allowed to guess and check with the same number that you've already used. I am allowed to try negative 1 in this new problem. And so that's what I'm going to do. So 3 times negative 1 to the 3rd plus 8 times negative 1. I'm definitely not going to try a positive answer because I can't get any positives. And negative 1 works again. So we've talked about this. This is the 3rd time we've talked about this. If negative 1 works again, that means it has a multiplicity of 2. It counts as 2 answers. It also means I can do synthetic division again with that negative 1. I'm doing it again with the smaller version. So my goal is to keep making this problem smaller and smaller and smaller until I can either factor it or I can use the quadratic formula. Now, unfortunately, on this problem, see if I can make another little section right here. These problems get really intense. Don't be afraid to ask your teacher for scratch paper tomorrow. Okay, so I have 3x squared plus 5x plus 1, and unfortunately for us, it's not factorable. I don't know two numbers that multiply to 3 and add to 5. And so at this point in time, you would do quadratic formula. We currently have two answers, a -1 and a second -1. We need a total of 4 answers. And so, quadratic formula will get me those other two. So quadratic formula is -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. It's -5 plus or minus the square root of 13 over 6. Don't forget, you should try to factor tree the 13. See if you get any pairs of numbers. 13, unfortunately, well, fortunately, is prime. I can't factor tree it, and that means I'm actually done with this problem. And remember that this counts as two answers. One answer where it's -5 plus the square root of 13, and then the second answer would be where it's -5 minus the square root of 13. And so again, even though it looks like we only wrote two answers on the answer line, we have in fact written 4. The number -1 counts twice, and the plus or minus symbol gives us two different options for that crazy fraction. Guys, I think we did it. I think I answered all your questions. I hope I answered all the questions we had time for today. I know that some teachers will be available in the morning. I'll probably be in my room around 7:10 if you need to just pop in really quick before school starts and ask some last minute questions. You can rewatch this video. We did a lot of really heavy math on the video, practiced a lot of stuff, and I'm gonna go ahead and sign off now. And I wish you guys all the best of luck on your test tomorrow, and a happy Thanksgiving if I don't see you. You're welcome.